Okay, I think the official clock says 12 o'clock, and I guess most of you want to get to lunch as quickly as possible. So I will start. My presentation, a little warning, there won't be much code. It's non-technical. Yeah. Documenting code, patterns and anti-patterns. The content of this talk, a short introduction, speak a little about myself, and then I will discuss documentation. What documentation do we need? And I will have a final section about commenting code, comments in code. And that's where the patterns and anti-patterns come in. This talk was inspired by a code review I did. There was a piece of code, and I haven't found it. I can't find it anymore. And the code was complicated, and the developer who committed the code had put a comment on top explaining the code. And I looked at it and I understood it after reading the comment and trying to figure out what it did. And I suggested, shouldn't we refactor this into some code that is easier to understand, and then we can eliminate this comment. And the developer agreed with me fully and said, oh yeah, that's a good idea, let's do that, and he did it. And I got the inspiration for this talk, mainly because this developer that committed this code wasn't a newbie, he wasn't a bad developer, he's actually a really good developer and usually writes really good code. But he fell into this trap of saying, this is complicated, I will just write a comment here and then commit it. So, I had this idea to the talk. Please don't comment your Perl code was the title. And I thought, that's a little negative. It's like, don't do that. You don't want me to stand up here saying that. So I changed it. Don't comment code, document it. Still, it started by a negative, not so good. So I came up with this final title, Documenting Code, Patterns and Anti-Patterns. Actually, I'm not fully satisfied with that as well, but here we are. And the whole point of this, me talking about the title of my presentation, is that writing documentation or coding is hard. You rarely get it right the first time. So you rewrite or you refactor, and you do that over and over again. And there's no, that's a good thing to do. This talk, although it's not really technical, it is meant for developers. It's about documenting code. It's how to make it easier for the next developer. And remember, the next developer might be you in 3 months' time when the first bug report comes in and you look at the code and say, who wrote that? Blame. Oh. How did this even work? Okay.
That's never happened.
No, I know. Well, a little about myself. I'm a freelance consultant. Mainly been involved in web development. For the last couple of years, it's been back-end development, microservices. I also do a lot of build and release maintenance management, testing, continuous integration, DevOps. I've been a professional developer for more than 20 years now. And one of the first things I learned, taught myself after starting to work professionally, was Perl. So I've been programming in Perl for almost as long as I've been a professional developer. I like to work with both back-end stuff, front-end stuff, infrastructure, whatever. I also like to develop in many languages. And I actually enjoy writing documentation, if it's the right documentation. Not stuff that a customer says, oh, write this, and oh no, they want this system architecture, whatever thing that no one will ever read. So, documentation. Usually it's not a popular subject. No. One of the problems is that it needs to be in sync with the code. Has anyone here written a system documentation? It's a big bulky thing that describes the whole system, and the first time you fix a bug or change something, then it's completely out of sync because no one wants to fix this big bulky thing. But often, especially when you do consultancy work, customer wants this. Some time back in time, someone says it's a really good thing to have this system documentation that describes everything. Yeah. Exactly. Exactly. All you do, as we did in a company I worked for once, on the second or third page, there was a footnote saying, if you read this, call our customer support and you will receive a bottle of whiskey. No one ever called customer support for that whiskey. It's extra work, and it's often missed, skipped, something you do just in the last minute when it has to be done, and it's really a waste of time. So, how can we minimize some of all this documentation that sometimes people require? Well, one thing is to write some code that is self-explanatory. Then we don't need to document the code, really. We still need some kind of documentation that isn't code. Oh. Yeah, okay, sorry. I was mixing up my slides, but it's okay. Self-explanatory code. How do we do that? I think we all know it. It has to do with naming, meaningful names, short subs, trying to do a little thing that is easy to understand. Minimizing the block level is another thing. Refactoring things out of a loop. And a module, a sub, should really only do one thing. Then it's easier to understand. And don't be afraid of a one-liner sub. I mean, then the sub has a name, and the name explains what it does, and it might be some logic, whatever, but then when you use it somewhere else, it's self-explanatory. And comments are really rarely or never needed to explain the code. And I have two good quotes here. First one from Martin Fowler: any fool can write code that a computer can understand. Good programmers write code that humans can understand. Yeah, you can make the program compile or run, but that doesn't make the code good. The next developer has to understand it. And Raymond Chen has another one: code is read more often than it's written, so plan accordingly. Again, you write your code, a month after that, you have to read it again, and maybe the next week after that, and a year after that, you have to read it again and again. Other developers have to read it. So it's important that the code is understandable. How do we ensure self-explanatory code? In other ways, tests. And I find that test is actually documentation. We have the unit tests, lower level, but also functional and integration tests using Postman, Selenium, JMeter, stuff like that. When a new developer comes in and looks at the code, he can say, is that test? Oh, there's a little test suite here that, it does a login, and then it does that. Oh, okay, now I understand the purpose of this. And of course, the tests, in contrary to written documentation, will be in sync with the code, because if the test fails, you have to go back and figure out, oh, I've changed something in the behavior here. Another important thing is when you're writing tests, your mindset changes. Suddenly you're using your code. You're not writing code, you're using your own logic, and sometimes it's like, no, this works in a weird way. I have to rewrite this because it's difficult to use somehow. And of course, you have continuous integration, but you should also run tests like in a daily, nightly job, because often there can be other dependencies, integration tests that suddenly fail because something else has changed. Another good way of ensuring self-explanatory code is peer review. You can use tools like Crucible, Garrett, pull requests to do that. Peer reviews is also a way of documenting the code. I know it's really fluffy, but if you're in a team and you really do peer reviews, a lot of people knows the code and understands the code, and everybody can take over. You don't have like, oh yeah, it's John who has this part of the system. I don't really know that code that well. That should never happen. So do the peer reviews, and then everybody knows it, and you don't really need a documentation. And remember to review, test, and documentation as well, if there are documentation needed. And another idea is to take a project module and make it the project of the week, project of the sprint, project of the month. Give it some special attention. Maybe it doesn't need anything, but it will be put into your sprint log, and you might have a checklist saying, okay, do a coverage test and see, are we missing tests? Check if whatever documentation might be there is up to date. Maybe it's using some outdated modules, whatever. Have this checklist, and again, there will be code reviews. You will look at it and you will make it a little better, and you might discover stuff that could be documented in the code a little better. And yeah, peer reviews, that's a really important thing. I work for companies where, no, we don't do peer reviews. It's like, yes, you should do it. It's a really good thing. No, we don't have the time for that. Okay, but you know, this time you're using now, if you don't use it on a peer review, it will explode at some time further ahead when something is broken. And Steve McConnell in Code Complete did some analysis of a lot of projects and had this little thing: software testing alone has limited effectiveness. The average defect detection rate is only 25% for unit testing, 35% for function testing, and 45% for integration testing. In contrast, the average effectiveness of design and code inspections are 55% and 60%. So you really get a lot of these bugs, errors, whatever, fixed before the code goes into production. And we know when it in production, oh, it's costly. It can be really a serious problem if it hits production. So, what documentation do we need? I know this can be a bit opinionated, so these are my suggestions, what I like. The README file, I like that. Placed in the top level directory of the code. CPAN, GitHub also likes that, so I'm not alone. It should be really short. Have a short description. This is whatever, done for the customer perhaps. Have a copyright message. If it's easy to build, install, then write that. If it's difficult, you should probably have a link to something, a wiki homepage saying, this is a mess on Windows, look at the wiki for further instructions. And you should have links to, of course, whatever all the resources are available. Don't fill the README with known bugs and stuff like that. That's kind of what you did in the old days when people didn't have internet connection all the time. Then it was nice to download some project. You had a README and it stated a lot of information that you needed. But nowadays, it's much easier to just go online and find out more stuff. And the first thing is the issue tracker. The issue tracker is also part of the documentation. Yes, it's dynamic. It changes all the time, but it tells you about known bugs. It also tells you about upcoming features, wishes. It even tells you about how far away from the next release you might be. And you can easily prioritize whatever features you want out next. And it really is one of the most important tools in any development. And I think I use I use it for myself, for my own small projects, but of course, even more important if you're in a team of developers. A wiki is also nice. You can write some technical notes. Again, this build is a little difficult on this platform. You have to install this manually and do whatever, blah, blah, blah. You can do it to communicate ideas like drafts of new APIs or something. Have a FAQ, knowledge base, stuff like that, and maintain some user communication, documentation. That's not always an option. Again, sometimes we have customers or whatever who says, oh, we need this 3 copies of this in hard print, whatever, and you have to do that. Some more specific documents that I like to have in all projects. Architectural notes. How are we building this? Why are we building this in this way? And it's notes. It's not a big bulky thing. It's a slight, small diagram saying, oh, we have a database here and 3-peer system here, and oh, then we have some third-party dependencies over here, just to have a simple way of introducing a big complex system to someone. Code style guidelines is another important document. You could just point at the official code style document and say we're using that. You could also point at it and say, yeah, we're using that, except we have a few things we're doing a little different. A server/deployment diagram. Again, we're not talking about the network topology and firewalls and all this low-level stuff and zones and whatever. No, just something saying, oh, we have these 3 servers and we deploy some middleware here, we deploy an Apache server here, and our stuff is going here. It's nice. The first time you sit and look at a system and someone say, oh, there's something wrong with this thing. Oh, where is it running, really? It's part of this. That's nice to have. ER diagrams if you're using databases. I usually also generate them with a tool called Schema Spy. Then it's always up to date. And all this should be somehow available in your wiki, of course. And then again, yeah, your company, your customer might have other documents that they require you to fill out or deliver, and yeah, then you have to do that. Comments in code. This was actually how it all started for this talk. Comments. They are kind of a documentation, but don't comment code was my initial statement. And Robert C. Martin says it. The proper use of comments is to compensate for our failure to express ourselves in code. You should fix the code by refactoring or rewriting. Don't comment bad code. Write it in another way. But comments can be used for good. They are in there for a reason. In other words, we have some patterns and some anti-patterns when it comes to comments. The patterns, good kinds of comments. What I call the file header. These are my own names. I haven't really found anyone structuring this in any way, so I came up with some names for it myself. Comments at the top of each source file. It can be good. A short description. This is part of project XY, written for this customer, and perhaps copyright information. Copyright information should usually be injected automatically somewhere in your build or whatever. That's easier. Sometimes the README file might be enough if it's a smaller thing, but if it's a big thing, it might be nice to have, oh, this is part of this. The why and comment. Sometimes you have to add technical depth. That's a bad thing, but sometimes you have. And this is often one of the places where people come and say, why is this doing that? So the why and comment will document why you had to do it and how this can be eliminated. And then, sorry? Yes, of course. Mm. Yeah. That's true. It's similar. Yeah. The question was, or the comment was that you could have a third-party dependency with some badly named interface, whatever, that makes your code look ugly, and you can't really do anything about it. I would probably do something like that. Say, yeah, this is auto-generated from a whistle file or something from this third party, and yeah, they don't believe in types or whatever that makes this code look horrible, and there's really no way of fixing it. That would be the end, because unless they fix their end, we can't do anything. That is true. You could do a wrapper, but then the wrapper would be ugly. So, yeah, but it's actually a good idea, because if you have something that's called a wrapper, you know, okay, it wraps something, but I would probably still have a comment saying, yeah, this wraps something that is ugly, and we can't really fix it because someone bought access to whatever third-party system. But I think a wrapper is a good way of fixing stuff, and again, documenting, oh, we had to wrap this because it was ugly. Helpful links is another good thing that can sometimes be used. You might have some really strict requirements, and they might lead to some code where you say, why is this like that? Oh, and there might be a comment saying, oh, this is to fulfill requirement B225 or something like that. And then people, oh, I have to look in those requirements. Oh yeah, they're weird. Or it could be like this: calculate pi using the last formula. I can't remember that formula right now, but you could put a little link to Wikipedia, so the next developer will say, that's how it works. It's probably okay. Public APIs. That's probably the most important place to use comments. When you're writing a module that other people need to use, it's in pod markup usually, and we still have the problem here that documentation has to be in sync with the code. Here the documentation is really close to the code, so it's a little easier to achieve that goal, but sometimes you fix something and then you forget to update the documentation. Then you have a code review, and the reviewer of course will say, oh, you missed the documentation here. Anti-patterns. Again, this was really how it started. Stating the obvious. Yeah, initialize counter. I don't even think you have to be a programmer to understand that line of code. I mean, I've seen other examples like instantiating customer object. Yeah, you have a class called customer and you say new. Again, we understand the code. So this is just noise. Remove it. There will be one more relevant code line on your screen when you remove that line. That's good. Refactoring in comments. N is number of files. Yeah. And you at some point figured out, oh, N is number of files. That's what it's used for. So you wrote that comment, but you kind of spotted that there was an issue that somewhere further down the code, it wasn't really obvious that what $n was. Refactor this. Call it number of files. Then we can eliminate that comment as well. Issue tracking. The to-do tags. How many here use to-do tags? A few. Okay. I used to do it. They're called source code tags. And there's also the fix me and the XXX. Yeah. And yeah, they're not really good. I use them sometimes before committing, when you're writing code and something isn't working, or just put in some stop method somewhere and saying, I have to put some real stuff in here, not just return one every time, then you do it to do. But before I commit, I usually remove those to-dos because it's much better to have them in an issue tracker. That is a good idea too. Yeah, you can actually replace the to-do with a link to. Yeah, you could do that as well. Yeah. And of course, the good thing with the issue tracker is it's visible to managers and other people. It's easy to prioritize and search and so on. These are not that operational in that way. Yes. Yeah. But that's another problem with to do. If this was an issue, you would be able to comment on the issue and say, what is this? Do we want it to or not? And that would be much easier to communicate what the actual problem was. And then, of course, often these to-dos also gets out of sync. That people will fix the code and forget to delete the to-do, and then you still have this to-do lying around somewhere, and it gets even more confusing. Yeah, I know. And you could convert it into a YAPC comment in some cases. Yeah. Yes? Mm.
Now I have the knowledge and I have to change it and these places. So later to do would be helpful. Immediately I make it to the search. Oh, yes, you know, it would help me.
Yeah.
Would make this part less in a month and less time.
Yeah. And that's also why I said you could convert it into a YAPC saying, this is not thread safe because I didn't have the time, and it can be fixed if you do this. It's also a way of expressing that. But again, if you're doing a library, the fact that it's not thread safe should probably be in the pod as well. And then maybe you don't need the to-do statement on a line on its own. But yeah. And then there's disabling code. Yeah, this was like this looks like a debug statement, and now we don't want it. It's like it's some old unused code. Just remove it. I mean, you're using version control, so you can get it back if you suddenly realize, oh, I didn't want to remove that anyway. If it's really important to you, you could put in a branch where it's enabled, or you could use a feature flag or a debug flag. This would probably be something like say count equals $count. If debug would probably be nicer. And that's it. You have to write self-explanatory code with tests. It's a really good thing. You have to do formal peer reviews. It's really important. And then eliminate all those comments. And maintain a minimal set of documentation. And we have 2 minutes for questions, if there are more comments. Yes? Yes, Donald Knuth's literally programming, yeah. It generates a lot of noise in the code. I find it hard to read. It kind of have all these explanations, and it's still comments. I mean, I would rather have the code to explain what it's doing with naming instead of having this. And yeah, so I know it, but I'm a big fan of LaTeX. I like the thing that it produces in the end, but no, I don't think it's a good idea.
If you make a comment, this is probably a bad idea. Most likely you're afraid to be comment the code.
Yeah.
I prefer to have comments for people who are capable of using it.
Yeah. Well, just as the code, the comments are subject to peer review. And what I'm saying here is also look at the comments and say, oh, this comment doesn't make sense. The to-do, you didn't understand the to-do. So if you were reviewing my code, you say, you should review the comments as well and say, what is this? Could we rewrite that as well? Just as I said with the title, writing stuff, that is a comment, for example, and coding, both disciplines are difficult. And we need to have both of them into the loop in our development process. Yeah. 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 Yeah, that's a good, I mean, generating documentation from live code or testing the code in the documentation with the current version of the code is a really good idea. I don't know how many does that, but it's important. Really? Cool. Ah, nice. Didn't know that. Yeah. I think it's lunch now. So thank you.